thank you for coming. I can promise you that it's going to be fun. And hopefully it will be useful as well. And I didn't know how to call my talk. Because of that, you probably seen two different titles in different places. But I basically call it OOP in pictures. And a little bit about me. I do some teaching. I teach people who learn Ruby as their first programming language. I do some educational websites as well and online courses. I do freelance consultancy for like 15 years. In most of the projects I work with legacy code, and therefore I call myself a complexity fighter. I used to work for GitLab for 1 year, and also I'm a Serbian Siberian. And let me explain what it means. Because I asked a few people, and they found it confusing. And actually, I'm Russian. Like most of the Ivans in the world, they are from Russia. And I was born in a city which is called Omsk. And recently, I learned that much more people know about the city called Omsk than I ever expected. And the way they know it is that when people fly from some European city to some Asian city, and for example, their flight takes 14 hours long, and right in the middle of their flight, when like 7 hours already passed, and there's 7 more, at the point where you feel the most desperate and bored, you look at that monitor, which shows you like the status of the flight, and there's almost nothing around and only one white spot indicating that you're flying over the city called Omsk. This is how most of the people know about Omsk. And yeah, and Omsk is located in the part of Russia which is called Siberia. It's not a country, it's mostly, I think it's the same like West Coast and East Coast here, some area. But I live in Serbia. And it is important, it's a country, and it's not Siberia. So, and I lived there for 5 years already. And if someone would ask me, what is the difference between Serbia and Syria before I moved there, I would be really surprised that it's actually 2 different countries. So, it is important that Serbia is not Siberia and it is not Syria. And here, 3 different words. For an unprepared person, they have the same meaning. And in the mind of such person, it simply means that means some distant location and distant and probably weird location. And we're going to be talking about the opposite problem. When some term has different meanings in the heads of different people. And this happens because a lot of things we deal with in programming, they are abstract. And they're built on abstractions on top of other abstractions. And this is because of that, it is really hard to teach students. Because of that, it's really hard even to make sure that the person you're talking to has the same understanding of the term you're talking about. And on the other side, yeah, and all those rules, all those principles, they are like high level and they are abstract. And on the other side, we have code, which is very low level and is very concrete. But when we have a lot of code, it's really hard to see the big picture. And there are things that try to fill that gap. And for example, CRC cards and UML, but no one really uses them and no one really likes them. And what we're going to try is to fill that gap today. And what you can expect here, first of all, as I said, it's going to be fun. And probably you'll be better at learning, teaching, explaining complicated concepts, visualizing big picture in your projects, finding architecture flow, and tracking changes in dynamics in your code base. And the talk is going to consist from 3 parts. First of all, we will build the foundation. Then we're going to use that foundation to explain some advanced concepts. And then we're going to use them in practice to see if it's actually useful or not. So let's get started. And for me, it all started on another conference in Russia. It was also Ruby conference. And I had a conversation with few other guys who are also involved in teaching. And we were complaining that, yeah, OOP is too abstract and it's really hard to teach OOP to students. And I said, wouldn't it be great if we could illustrate things like dependency injection in just one picture, and so that everyone understands it correctly? And I said it, and I forgot it. And then later, I was preparing. I started teaching to students again, and in the course I'm teaching at, they have a task. And the task sounds like this, that they should develop a smart electric kettle that should boil water correctly and safely. But they shouldn't write any code. And they should just come up with the number of classes and the methods. And this is their very first task about OOP. And for some students, it's really hard. And to help such students, I used a method which I called artistic soldiers method. And the way it works, I'm simply saying, imagine you're an officer and you have a squad of soldiers, and by some lucky coincidence, they are very artistic. Whatever role you assign to them, they become so good at this role that if you assign a role of a shovel, you really can dig holes with this guy. So, and you have a mission to boil the water safely and correctly. And now you have to come up with these roles. What would be those roles so that you can accomplish this mission? And once you assign the roles to the soldiers, there are 2 ways you can interact with them. First, you can ask them to do something. And the second, you can ask them a question and they answer you. And then suddenly, one by one, students start having an idea. So probably we should have we should be boiling water. Someone should be boiling water, like it should be a boiler or a heater, something like this. All right. Then, in order to for our kettle to be safe, we should detect whether there is water or no. So there should be a guy detecting that fact. And then probably someone should measure the temperature, and so on and so on and so on. And now we have 5 roles, which you already know, which are 5 classes to solve this problem. It's not necessarily this set of classes. That could be a different way to solve this task. But when I saw this again, this picture, everything I illustrate with this kind of pictures. And I remembered about this question I raised at the conference about illustrating dependency injection with a picture. And I thought, what would be the next step to move to that direction? And I realized, all right, we have roles, but we also have methods. How would methods look like on this picture? And the answer is, well, we can use arms. So now we can illustrate objects with their methods. And some of guys have two arms. Some of them have only one. Probably there could be objects that have 5 or 3 arms or limbs. That doesn't really matter, but yeah, looks interesting. But then it looks like hands are not simply hands, because methods are accepting arguments. This is more like a robot hands, and fingers are more like tubes where you can pass some arguments into. And the more fingers you have, the more arguments you can pass. There could be a method without arguments, there could be an arm without fingers as well. So, and the way you call a method is like you are shaking someone's hand. So, and also, like if you're passing an argument, our guy, and we see it's not a simple guy, it's already a robot, some kind of a robot. Our guy can remember a value into his brain and then reuse it in another method, right? All right, let's move on. But how other stuff is going to look like in this case? So first of all, it looks like our guy should be returning objects somehow, and there is a body on his, there is a door on his body, so that like something happens when like then arguments are passed into the method, and then the result comes out from the door. What about private methods? It looks like those are some kind of internal arms which no one from outside can shake, but he for sure can do it. What about handling exceptions? Like it's not very, like exception itself is like something went really wrong, but handling exception, it looks not very nice, but that's what we have. We can't do anything anymore. Like we're just describing like our little universe. It's not already in our control. And with this set of rules, we can already illustrate some basic anti-patterns. Like for example, if the hand has too many fingers, if a function has too many arguments, probably it's not very convenient. And what I like about it is that if it looks weird, then it's probably going to be weird in the code as well. And too many methods, and also too long methods. So yeah, it's very hard to deal with long hands. And my favorite one is the swollen. No, it's too many instance variables, of course. Like yeah, it's very hard to remember all of them. And my favorite one is the swollen arms. It's where you have so many conditional logic inside the methods, so that arms get bigger and very hard to deal with them. And of course, like there could be a combination of all of those problems, and unfortunately, this is how like most of mature Rails application look like, but that's what we have. And yeah, and that was the first part. And now on to the second part. And now we can illustrate a more advanced concept of polymorphism with this idea. And right now it becomes really obvious that polymorphism is just the same set of limbs with the same set of fingers. That's just it. And of course, we can have partially polymorphic objects. And for example, these guys, they are only partially polymorphic because their arms are different, but their legs are really polymorphic. So we can use them in the same scenario, and the code will work just well. All right, what about classes? Because we were only talking about objects, but programmers don't design objects, we do design classes. And for classes, it looks like it's more like a spawning platform where we as programmers, we develop instructions to those platforms. We put some cartridge with this instruction into those platforms. Then we pull a lever, and then our object gets instantiated. So yeah, and then we are like looking at those two things, and we see that they kind of have the same topology, because the lever and the arm, they look really the same. It looks like just that lever simply doesn't have fingers, but it could have. Like lever is just a method as well, and here it doesn't accept any arguments, but it could. And the door on the body is the same thing as the hole where like object gets spawned. So they really have the same topology. And to explain what topology is, I can show you this beautiful animation. Yeah, so it basically says that the donuts and cups, they have the same topology, or like they have the same essence, if you like. And we also have to remember that arguments are objects as well. So we remember that classes are objects in Ruby, and we see it here, and arguments are objects too. And it's kind of weird. And you can say, what a weird universe. But then I can remind you of our universe, which has like quantum mechanics and all this cosmology stuff. It's pretty weird too. So, all right. And what about execution flow? It's really interesting what's inside of the ARMs right now. And it would be tempting to say that all those little sections are just instructions which get executed one by one, but for most cases, it wouldn't be true, because like in reality, our code is much more complicated than that. And I would say it's more like a very complex aqua park with interconnections and loops and merges and this kind of stuff. And another analogy I found pretty similar is the Rube Goldberg's machine. And this is where like you place a lot of objects in a special way, and one ball starts to roll, and then it triggers one effect, and triggers another effect, and something happens, and in the end you have a cup of tea, for example. So I would say that we, as the developers, when we design our methods, we design something similar. We align the internals of those arms in the way so that when objects fell through the fingers, and I know it sounds crazy, if someone joins us, it will sound very, very crazy for him. So, but we design those paths in a way so that while they fell into those tubes, their hands got shaken, so they touch with their hands certain obstacles, and the methods got triggered, and the values are returned, and they also fall down, and so on, and so on, and so on. So yeah, those are obstacles we are placing there. And also we have to introduce another concept here, the concept of dependencies. Because in an ideal situation, we have pure function where we have like our beautiful internal world of the ARM, and we don't have to use anything from outside. But sometimes we have to use stuff from the outside, and I'm talking about some globally available classes or modules, and we can illustrate it so that the guy has to remember about them in order to use them inside the execution flow. And we're placing them inside of those tubes so that their methods can be triggered to their hands can be shaken too. And some of those dependencies, they interact with the external world. So they have to, I don't know, they have to save something to the database, they have to interact with network, and so on and so on. And it looks like, in this case, our arms are going to have holes in order for our method to work properly. And right now, we already can illustrate dependency injection at this point. And it is simply that. So in the first case, where in the first scenario, our guy have to remember all those things which we are using inside of methods, and it results usually in side effects. And with dependency injection, we just pass those things as arguments so that there will be no holes like this. And we can say that those side effects, they will be channelized through the fingers. So that's what we have. And we already achieved our goal. We illustrated dependency injection with a picture. I'm not sure if it makes sense, actually. Does it? Thank you. Okay, and then let's try. I think we can play with this for a while, but we're going to continue to our third part, and let's see how we can try to use it in practice. So we've developed a visual language which describes the rules of I don't know, of interaction of objects and classes and all of the stuff we have in programming. And I tried to use it in practice, but I decided to use Sandy Matt's talk, code from her talk from last year, because I found it very illustrative and very typical. If you haven't seen this talk, I highly recommend to do it later. But for now, we're going to be just using the code, and it's not really important what the code is about. It is important that in her talk, she says that like there's a regular situation, like you have a set of requirements, and then something changes, and you have to rewrite your code, and something changes again and again, and then your code gets complicated and more complicated, and in the end, we have something like this. And what we're going to do, we're going to use our language, and we're going to visualize this code with our little guys with arms. So the first requirements lead us to this kind of code. And we see here that we have one condition here, and we can draw this guy. So we see that there are 4 instance variables. There are 4, does it work? No. There are 4 arguments in the constructor. There are 4 legs which I use to demonstrate those auto readers. And there is one method, and you see this arm represented this method has one swollen arm, indicating that we have one condition inside. And then another set of requirements comes, and the code gets more complicated, and our guy gets more complicated. Now we see we have one more swollen section in the arm. We have one more instance variable. We have 3 internal methods now, and one of them is kind of long. And now we see in dynamics how our system changes, and we see it's getting worse actually. And then it gets even more complicated. Then we add another section to our private method, and in the end, it looks really weird. So we have a public method with 3 swollen sections and like a bunch of private methods, and now you can see that, yeah, this code is weird. But you can compare, like, to understand that, without this picture, you have to go through all the code and like really analyze it. But here you can, like, you see it very easily that something is wrong with this code. And yeah, we can actually build some kind of diffs using this technique. And we can see, like, at the beginning we had pretty simple class, and in the end it got really, really weird. And 2 things I've learned from my own practice, like on the projects I was working on. They are not related to that code, and I was modeling one part of my application, and I realized, like, there were several classes, and I had to add one argument in one for one method of one class. And then I realized that I have the same argument in other places. So this thing helps to helps to detect some kind of dynamic anti-patterns which you can't, like, catch easily when you have just a code. And another thing is it's also self-replicating. When you had to add one condition to one method, you can find yourself in a situation where like the same condition starts to appear in potentially even unrelated code in your application. So this is also becomes very easily recognizable with this approach. So, and then we just quickly go through the refactoring process which Sandy shows. So there she takes this, our little monster, and step by step refactors it to a simpler object. So I will just show briefly what she gets. So because the code itself is not that important, it is just, you see that we now introducing more objects, but they are much simpler than the first one. And more and more, and here she introduces a class with a called clump, which plays the role of factory, which returns different, which might return different objects depending on what's passed to the method. And in the end, we have something like this. And what I like about this picture is that it shows that actually complexity didn't go away. So the code is still complex, but the complexity now has different form. And it means like that either you choose to have really complicated logic inside ARMs, or you have to have somewhat complicated hierarchy of objects. But it's up to you to choose what to do in every specific situation. And that's almost it. So what we did, we developed a notation, a visual notation, which we can use to explain things, to teach others. And yeah, all models are wrong, but some are useful, and I hope this one can be useful. And yeah, what can we use it for? Like to draw a big picture of your application or of a certain part of your application, to model stuff, and the same situation as we had with the electric kettle in the beginning. You can use it for this. You can use it to document some places of your applications, and you can use it to share knowledge, because like sometimes it's much easier to show one picture rather than going through like a lot of code. And yeah, explain stuff as well. So that's almost it. If you follow this link in QR code, there are a few links to Sandy Matt's talk, and some other links, some other related links too. And this whole thing is a part of my ongoing long process of developing something that's called painless Rails, which like it's my goal to describe a process of how you can use Rails in a way so it doesn't hurt you. And this part is specifically about object-oriented programming, but yeah, if you're interested in this specifically, you can catch me later, and I'll probably tell you more. Thank you. If you have any question, I can answer